All right, so let's get started, and happy to see people already joining. So welcome to this week's PTC Talks, where we are happy to have Dave Duncan, who is our Vice President of Sustainability at PTC, for a session on product footprints, preparing for the new CSRD compliance priorities. And just as a background, Dave has just spent 3 months of a trip across EMEA, meeting hundreds of companies discussing sustainability. So he's definitely having a lot of recent findings to share today. Let's start with a very quick introduction by me. So my name is Torbjörn Peterson, and I'm the Alliance Manager for PTC, leading these webinars, where we invite customers and partners for some inspiration on digital transformation to see what is possible and how to make things happen. And we are running all these webinars on Fridays, same time, with topics around either manufacturing, services, or engineering. And the recordings are to be found on the registration site. The agenda for today is first a very quick overview of PTC by myself, and then Dave will run the show where he will touch base on a few challenges, how to address these, and then explain some of the business outcomes. And at the end, we're also having a Q&A session, so please keep your questions to the end, or you may also put them in the chat and we will pick them up a little bit later in the Q&A. Next slide, Dave. So just a very quick introduction to PTC for those who don't know about us. We are a global software company with a headquarters in Boston, and we provide market-leading solutions on IoT, augmented reality, PLM, CAD, SLM, and ALM through the digital thread to help companies to accelerate their digital transformation. So now over to you, Dave.
Thank you, Toby. For the next 20 minutes or so, we'll cover the high points of CSRD and how it matters most for life cycle practitioners. So if we saw you during our tour, excellent, welcome back, great to see you again. If you weren't, we'll still provide proper context so you understand this briefing, but we'll spend the next 20 minutes or so talking about the high points of a tour that we did recently in Europe over about 11 weeks or so in 22 locations. Where we ran sustainability workshops with partners, employees, customers, academia, to get a deeper understanding of what the needs are for environmental footprint reduction in your products and how product lifecycle management can help. And what I mean by product lifecycle management is the enterprise levels that include ALM, CAD, PLM, IoT, SLM, AR, etc. So first, in terms of the scope of sustainability that we cover as product lifecycle practitioners, sustainability is a large scope, and we play in a very specific area of this. So sustainability includes environmental, social, and governance. As lifecycle practitioners, we largely focus on environmental. Yeah, there's a few aspects of social that we bring over in terms of data fields, like suppliers have to be labor compliant, etc. And those would be attributes that we would bring over in supplier management. But for the most part, we focus on environmental. And within environmental responsibilities in sustainability, there's 3 tasks to do. 3 main tasks that CSRD and other regulations require. One is greenhouse gas accounting of your entire corporation. The second is footprint reduction for your corporation. And then the third is disclosing what the climate risks are for your company. As product lifecycle practitioners, we focus almost exclusively on product footprint reduction, which can include measurement at the product level. But that doesn't really feed into greenhouse gas accounting. That's more meant to drive down the footprints of your products. And within the footprint, there are many areas of footprint that could be relevant. The areas that are common across all products are the following. It's to decarbonize those products, control the hazardous materials in those products, and what we call finite material preservation, which gets into circularity. But circularity also has correlations with decarbonization that we'll talk about soon. And there might be some other areas for your particular product. Like a common one would be water usage. Some products for the manufacturer sourcing of it can be heavy on water usage, and those would be other attributes that you might bring over for certain products. So we'll focus largely on these green areas this morning, or this afternoon. I guess we're talking mostly to Europe at 6 a.m. here in America. Okay, just to review for CSRD, if you're not aware, this is a topic that we covered during the workshop, is the Corporate Sustainability Reporting Directive is broad. It covers that entire scope that I showed in the previous slide for your corporation. But as life cycle practitioners, we focus really on three mandates that come from the CSRD. One is reporting footprints, and here I would say would be at the product level. And then the second is committing to science-based reductions, mostly on the carbon end of the footprint of that product. And the third is to, this is a later phase of CSRD starting in 2027 or so, is you need to prove that the material that you introduce to your customers is eventually recovered back into the economy and not wasted or burned. And the penalties are prohibitive if corporations don't abide by CSRD. First and foremost, you'll lose your customers, particularly if you're B2B, since your customers will be looking for CSRD compliant manufacturers. But there's additional fines that vary per country, and some countries even have criminal liability for their corporate directors for non-compliance. Now, some good news with CSRD as well is that you're not alone in the European Union. Non-European Union exporters to the EU have to abide by CSRD on a 12-month delay from you. So it's a level playing field, but you have to adopt it first if you're in the European Union. A couple compliance items that come from this. The first is an environmental product declaration called an EPD. This looks a bit confusing, but it's a standard output of the environmental impacts of your products. The good news is what we've learned during the tour, as well as other research, is this output can be largely automated from a high quality bill of material that would be accumulated in PLM as it goes through a function of a life cycle analysis. And these are things that you can run early and often in design as predictors of what your ultimate environmental product declaration will look like, so that you can adjust your product designs as you go while change is less expensive. Otherwise, to do this manually is quite expensive. In terms of euros, I'd say 30 to 60,000 euros per variant that you offer to deliver this, but with automation, you can largely take most of that spend out. Most of the scope of this is what we call cradle to gate, which is what is the environmental product impact of your product the day that it comes out of the factory. And in 2025, if you're a large manufacturer, you usually have to report at the corporate level, not necessarily at the product level. So I would expect regulatory as well as market pressures to come for these types of disclosures early 2026 and beyond, depending upon the size of your company, where you're located, and type of product. The next thing that's going to come is the digital product passport. You have a little more time for this. 2027 is the first year of it, and that's where batteries go. So if you deal with large or medium-sized batteries in your product, you'll have to report your battery. The intent of the digital product passport is to have a digital record of your physical assets while they're in the field. And it takes this environmental product declaration as its initial post, but then it posts other I would say operational and service activities in your digital product passport for the purpose of tracking material so that it comes back into the economy. So who owns it? Where is it? What parts have you changed off it? What happened to those parts? How do they cycle back in? When it reaches end of life or transfer of ownership, how is that tracked to ensure that the material comes back? So the scope of this is cradle to cradle. This will drive circularity, and circularity is essential for decarbonization. And what we've seen is refurbished or remanufactured laptop is 90% more efficient than a virginly sourced laptop. Mining equipment about 80%. So we're seeing somewhere in the range of 75 to 90% of remanufactured part efficiency in terms of footprint. Okay, the third is in terms of the CSRD compliance priorities is you have to make a commitment to reduce your footprints towards net zero. And this is the slope of decarbonization that's expected by the CSRD, where your company would declare a net zero date at the latest at 2050, and depending upon your company's aspirations as well as competitive pressures, it may come sooner. The first milestone is called the near-term goal, which is 2030, where you have to reduce 50% of your what's called scope 1 and scope 2. That would be your fossil fuel and electrical energy that you use mostly in your factories, but also your trucks and other things. They won't ask for your help with that too much. That's mostly procuring electrified or hydrogen using equipment, and then your Treasury Department procuring renewable electricity supply. But they will ask for your help is the second part, which is the 25% reduction of your top scope 3 categories, and we'll get into that in a moment. That will mostly be your materials and some other things. And then the long-term goal, which is considered the harder half of decarbonization, where you have to directly remove at least 90% of your footprint, that's going to get into some other things with circularity. You're going to have to get into the service business to some degree to do that. One, because of the digital product passport. And secondly, you need to retain some sort of ongoing relationship with your customers to ensure that you have suitable take back and recovery of your products and materials. You're allowed up to 10% of your original, what we call baseline emissions. So let's say you emit 1 million metric tons of carbon in the air today. You're allowed to have up to 100,000 left at your net zero date, but you have to pay money to take care of it. And what we mean by that is you have to pay a market-based fee to a real company that will sequester your carbon. And the current rates at that, or the expected rates of that based upon futures markets, are $70 per metric ton. So that'd be about 65 euros per metric ton. And that's real money. And this type of obligation is being baked into future earnings potentials of manufacturers. So a stock analyst will assess how is your company doing in its decarbonization and how much money are you expected to pay at this point. And I'll show you why this is material. So let's say today is the net zero date. And for net zero, any emissions that are left, you have to pay some provider to remove that carbon for you. In the picture that you see here, this is Climeworks, and they have machines that suck in carbon into an absorbent, and then they can bury it back in the ground, almost like reverse fossil fuel. The technology is not scaled. It's not quite down to, not even close to $70 per metric ton, but it has some years to get there. And the futures markets expect to get down to $70 per ton. And if it were $70 per ton that you'd have to pay to Climeworks, a company like PTC is a software provider, because we don't sell products with materials. That's pretty easy for us. We'd have to write a check for almost $3 million to Climeworks, but that's less than 1% of our annual free cash flow, and that's okay. But if you look at a typical manufacturer, a billion-dollar manufacturer, in terms of the emissions that a typical manufacturer has, that's that size, typical margin of 15%, the amount of money that you'd have to pay today would be over 100% of your free cash flow. And that really isn't, you wouldn't really be in business if you had to do that. So this slope of decarbonization is essential for the future earnings potential of the customer, of a manufacturer, and markets do take into account how well you are tracking towards that goal before you have to write checks. Okay. During the workshops, we covered this as the maturity progression of design for sustainability. Right? You can optimize at the part level, and then you can optimize at the product level, and then you can optimize at the fuller product service system level, and the product service system level is what you need to get to eventually towards circularity. Academia supports this progression, and that's what we started with. But a key learning from the tour was that for an established manufacturers prefer to start here. And the reason for that is, let's use this bicycle as an example. Maybe this bicycle has 1,000 parts on it. And of course, you have many different bicycles that you offer. Job one is to identify, where are you today in terms of your product footprints? And if you have 1,000 parts on this bicycle, what are the 10 parts that have the best potential for footprint improvement? And then you do cycles down at the component level to improve the footprints of those parts. Whereas otherwise, if you do it in the sequence of component to product, if you're trying to optimize all 1,000 parts, you'll have diminishing returns on many of those, and that's vastly suboptimal. And then the third would be to go towards circularity, because the regulations give you a little more time to go towards circularity. But another observation on product service systems that we have is companies that are forming today to disrupt established manufacturers are starting at level 2. Right? They see a competitive advantage of being able to be more agile to get to a product service system level, looking 5 years ahead or so, and they're starting to get there. So you're probably already getting some market pressures from competition on this level. So that's sort of some early thought as well. Okay. Next is, what are we doing as a company about this, about these priorities? So let's look at the cradle to gate process first. Cradle to gate is effectively means all of the sourcing of your materials and components and the assembly, and when they leave the factory, that is the cradle to gate footprint. And that's job one for CSRD, and that's what they're asking for in the EPD. So the materials and components that reach the receiving dock of your factory, they are often 75 to 90% of your footprint, because there's so much carbon intensity in the mining, the transportation, the processing, et cetera. Not only of heavy metals, but also the rare earth metals that require a ton of energy in your electronics. And then in the factory, yeah, you do some assembly and some transformation, but largely speaking, that's only between 1 and 10% of your total footprint that you report for a product. And for that cradle to gate, you report a environmental product declaration. So let's take a look at how that forms through the digital thread. What you see here in the middle is a bill of material object where you can have multiple materials that roll up to, say, a make part, and then you buy some components off the market. You can have optionality, and then it rolls up to your bill of material. So like for a bicycle, for example, you may be building your frame, and with your frame, you do some material selection of carbon fiber or aluminum or steel. You're able to pull over some of these sustainability attributes from your material database to synchronize with your bill of material, like carbon usage, water usage, percent recycled content, recyclability of the content, hazardous material compliance, etc. Now, you would largely get the same types of attributes from your components that you buy, like maybe some of your electronics or your wheels or other things that you might buy for, say, this bicycle, if we continue with that example. But those same attributes would usually be rolled up at the part level for you. So you ingest those same attributes at a part level. And likewise, for your make parts that you're creating, you're going to add some energy in the factory for the transformation of that material into your parts. And you can add that energy usage, carbon usage, water usage, etc., at the part level. And it's not limited to that. You would also add cost, some performance variables, other things to make a decision and roll this up. And as you roll up this data to understand the entire carbon footprint, water usage, material compliance, recyclability of your product, that's called a life cycle inventory that can be managed in a high quality bill of material. And along the way, you can do what's called a life cycle analysis. In product life cycle speak, we would call this a BOM-based environmental simulation. And as you're progressing your design, you can run estimates of that. And when you get in your final design, when you have a thorough bill of material, then you can largely automate that final environmental product declaration from the from the information that you have on your bill of material. So a lot of this is capable today, and there's items that we're enhancing in our product to make this easier and allow you to have more and more high quality information in your bill of material to drive this specific workflow. So we would recommend that as step one. Right? Get your bills of materials in order. Then you can identify your hotspots and do some automation of your product declarations. And then as you discover hotspots in your parts, then you can run loops to improve those parts. You can do that through better material selection, also using loops of different simulations like generative design for lightweighting, manufacturing simulation for identifying manufacturing process and how your geometry and materials interact with that, and also performance simulation to ensure you're still abiding by your stiffness, thermal, and other constraints. And even looking at additive in some cases and doing a multi-criteria analysis across footprint, cost, and performance there. This is largely available today in terms of being able to run these capabilities, these simulations, and do multi-criteria analysis on the attributes that you'd like to. If we take this to cradle, the step further, where you are assessing the full life cycle footprint and the take back as you start preparing for the digital product passport, then yes, you're starting to account for your operation and service footprint. That can vary widely by product, depending upon the energy that your product uses and the service intensity that it requires, central versus field service, et cetera. And then, of course, the take back of the spare parts and end-of-life product to disposition various components for reuse, remanufacture, recycle, which can cut off a lot of the energy that would otherwise be used from virgin source materials. And we found between 50 and 90% footprint recovery in these types of flows back to cradle. The compliance delivery there is the digital product passport for this cradle-to-cradle process. And here's what we're cooking to do this. If we pick up where we left off with the EPD generation for the bill of material, as a product comes off the assembly line, that initiates what's called a digital product passport. Our ServiceMax framework is strong for this. And fortunately, there's a strong standard that's taking hold called the Asset Administrative Shell that PTC is following carefully. It's EU-sponsored standards work done out of the IDTA that should provide good interoperability of data across your supply chain to feed this, not only for the initial posting of the digital product passport, which would show what did it look like when it left the factory, but secondly, the downstream activity that would need to post to this asset so you understand who owns it, how's it been operated, how's it been serviced, how is that service material returned back into the economy at the end of life, how is it disassembled, and each assembled component returned for reuse, remanufacturing, and recycling. Okay, and the third step that we are working on, and we invite customers to contribute to this as well, is within our team, we continue to research the best practices for design for sustainability. ISO 14001 is the guiding framework for that with eco-design, but it reaches out to these sub-specialties here, which we loosely call design for X, and more we're injecting these best practices and capabilities into our products. Somewhat initially with a requirements template in Codebeamer, but more and more to give contextual, I would say, hints and advice along the way, these best practices within the workflows of users, whether you're a designer or manufacturing planning or service planning. And with that, that's a kind of a quick recap of the high points of the tour and what's important for CSRD. What PTC is doing about it. We have some time for Q&A now. I'll leave this screen up for a couple of reasons. One, if you want to reach out to me with questions. And secondly, we have a sustainability user community at PTC. And with following the tour and some of these new developments that we're doing, we have 3 different threads that we're going to have discussions on and advisories on. The first is the cradle to gate in terms of preparing a high quality bill of material, how that's done, what sort of product enhancements we're offering to do that even better, reaching out to our community for advice on that. And then the cradle to cradle and footprint reduction threads are expected to start in October. So welcome anyone to participate. If you haven't registered, there's a link here. And once you register, it is a private community. Just pop me an email and I'm happy to set you up and invite you in the discussions. So thank you for your time this morning. Toby, let's open up for questions.
Sure, let's do that. And thank you a lot. Thanks a lot for sharing a lot of interesting stuff here, Dave. So, I mean, as we said, I mean, in the past, I mean, let's open up for questions. And I mean, please raise your hand if you have any questions, and we will just unmute you. So I can also see in the chat that we have quite a few questions. So I will pick a few questions here to start with. From Amit. How should our customer measure the product carbon footprint of their products, and what role is windshield playing in computation of PCF?
Yeah, good. I think a good way to, it may be oversimplistic to use this analogy, but it holds probably for like 95% or more of the footprint that you measure. View it as Lego bricks. Like your products are configured as different blocks, and each block would have attributes for the carbon intensity that it brings. So when you have materials or components that you source elsewhere, those would come with the accumulated carbon footprint up to the point that you receive it. And then you can do certain activities on that in your factory or even operation and service, and you can append the extra carbon that's done on those activities. So when we're showing the framework of the EPD, largely you hang those attributes on a material level, part level, or configuration level, and you add them up and roll them up from there. So we view the bill of material as the data aggregator and also the structure for doing those calculations.
Thank you, Dave. I had another question also as a follow-up from Amit. Are there any product which is integrated within the windshield to support the carbon footprint assessment, especially for scope 2 and 3?
Yes, there are. So we have, well, first I want to say that PTC is certified in PLM openness. So I will mention a few vendors that we prefer and offer pre-configurations with, but you can use alternative vendors since our architecture has open APIs to plug in other vendors. But I'll give a few examples. One for sourcing materials, Granta offers really good sustainability data. They have environmental scientists on staff that assess carbon footprints of various materials. And materials are getting more complex as you get recycled blends in them, and they will have different performance as well as sustainability properties. So one would be a material database. Grant is one we can pre-configure. Another is MakerSite. So MakerSite does life cycle analysis. I think the preferred integration point is at the bill of material, but you can also integrate at the CAD level to ship over your part as well as product information, and it will do a life cycle assessment of the impacts, and then you can do a hotspot analysis and make improvements from there. And as you get to late stage bill of material, a MakerSite can largely automate an EPD for you. And then in between, for simulation of manufacturing, a priori does a fantastic job at a part level to inform you as to what your added footprint will be from your manufacturing process. So if you think of Granta as the materials that are coming to your gate, MakerSite can cover the components that come to your gate, say a simulation like a priori to add what's going to happen in your factory. You accumulate that in your bill of material and then send that to MakerSite as an LCA. So those are examples of vendors that we integrate for those functions.
Thanks, Dave. I think I have another question also, I mean, a little bit connected actually to probably, I mean, the discussions you had during your road trip sort of, and that is related to. Have you seen any other renewable energy sources beside electricity gaining traction in manufacturing, or?
Yes, hydrogen in particular. If you look at, in particularly for generating heat, is on your production lines in discrete manufacturing, probably most of your machines are electrified. And if so, that's great, because over time, the electrical grid will become more renewable, and most likely your Treasury Department's investing in solar or other renewable generation for your factory, which will net out the emissions of those machines. But for the machines that need to generate heat, they're often natural gas fired today. But many of the providers of those heat sources and machinery are creating what's called dual fuel machines, so that it can use either natural gas or hydrogen. And largely speaking, the natural gas infrastructure in America, Europe, and other places can accommodate hydrogen. Some countries like the Netherlands are already starting to move to that. So yes, we're seeing hydrogen take off, as well as the, I would say, equipment and machinery infrastructure to handle hydrogen, but also give you the resilience to use natural gas where hydrogen is not available, or where it might not be commercially practical for you yet.
Thanks. Another last question here. So, I mean, generative AI is, of course, I mean, a hot topic all over the place.
Yeah.
But I mean, do you see also that AI is assisting yet, I mean, sustainability, or?
We do. Academic research backs this as well, in that for design for sustainability, you don't have to overhaul your product lifecycle management practices. Rather, sustainability is the fourth dimension of product design. You have cost, quality, performance. Now you have sustainability, and you have some sub-dimensions in there that you need to balance as well, like hazardous materials, carbon, water, etc., that can correlate or they can conflict depending upon your designs. So with those added dimensions to optimize on, yes, that's where AI can help you identify what the right trade-offs are of all those factors that we just discussed. And secondly, where we see AI helping, and these were from discussions during the tour, is during your hotspot analysis, it can advise you on what to work on, not just based upon what the most carbon intensive parts of your product are, because you probably already know what those are and you make many generations of those, but also based upon how much it changes, either goes up or down based upon similar other designs. Like an example of that would be a laptop. The motherboard is pretty much always the most carbon intensive part of a laptop. If a hotspot analysis just kept telling you that the motherboard was the hottest piece, that's not too useful after a while. But with AI, it has the potential to tell you, hey, for this new laptop that you're designing, this motherboard is unusually hot compared to similar laptops that you've designed in the past, so you want to give it special attention. Or maybe it's unusually better than other laptops that you've designed, and it might be a design breakthrough that you could use in those other variants or models as well. So those are two areas where we see AI have great promise, and we're investigating that.
Thanks a lot, Dave. Time is unfortunately running out. We still have a lot of questions coming in on the chat, but we will try, I mean, to catch up on those and answer you back on those, definitely. So many thanks everyone for joining today, and of course a very special thanks to you, Dave, for sharing a lot of interesting stuff here today. So with that, I hope to see you back at the next PTC Talks on next Friday for a session about design and source for sustainability with a priori. So with that, have a fantastic weekend and enjoy, and see you next week then. Take care. Bye-bye.
Good day.